All right, so in solving systems by substitution, a lot of times people say is why do we do it instead of graphing, which is what we did last time? Why do we tend to substitute? A couple of reasons, okay? Number one, you don't want to graph. Okay, that's one of the reasons why we substitute, is you don't want to graph. So if you don't want to graph, then you want an alternate way of doing the work. So what's an alternate way? Well, you can substitute. Okay, why else would you substitute? You feel more comfortable dealing with equations. In other words, you don't mind adding and subtracting to one side. You don't mind dividing, right? Like it's not scary for you to say, oh, I have a 2x over here. Let me move it to the other side by subtracting it or adding it. So you don't mind doing that. So if that's not a big deal, then why not try substitution, right? Especially if you hate graphing, right? The very first thing. So why do we substitute? There's a lot of people that don't like to graph. So they prefer another way. And also, they like doing the algebraic part of the math, right? The adding and subtracting. So the two things. Now, when you substitute, you replace pieces in another equation. Okay, so I'm just going to kind of put that right here. So when we substitute, we take a part of one equation and place it in another equation. And I told you guys that I'm going to try using colors when I do this so that you can see like, oh, here's the second equation, that one's in blue, but for some reason the blue equation just got something put into it that's in red. Where did that come from? Then you'll look at the first equation and say, oh, that equation's in red, so he just replaced something into another equation that came from the first equation. So I'll try to use color to kind of get you to see it, okay? Visually see the substitution occur, okay? So when we substitute, we take a part of one equation and place it in another equation, okay? So that's substitution. Elimination, which we're going to talk about on Monday, is different. Okay, that we just try to get rid of variables. All right, but for this one, we're just trying to move pieces side by side. Now, I am going to do work from your homework. I think I saw 8 examples. Let me see. I forgot how many there are. Yeah, there's 8 problems. So I'll see if I can do 3 or 4 for you guys. We always like to start off with something easy, medium, and hard, right? So I'm going to start off with something easy. Now, questions 1 or 2 are considered the easy type. So we'll probably go with just question 2. Right, let's do one that's a little tougher. But let me just give you a little insight into no solution and infinitely many solutions, so we can see if this is what happens with number 2. Okay, so you can get 3 types of answers. Okay, so let me put this right here. You can have 3 types of solutions. Okay, so I'm going to describe all 3 of them. So the very first type is a point. Okay, so you can have a point. In other words, it's going to look like this: A comma B. So like 1 comma 3 or negative 6 comma 8. You're going to get an answer that turns out to be a point. Okay? So that's the first type, the most common type. Okay? The second type of answer is no solution. Now, what happens with no solution is you work out 2 equations together, and what ends up happening at the very end is that you end up with something that looks like this. So you start with 2 equations. Now, I'm not being super proper. I'm really supposed to write y sub 1 equals m sub 1 x sub 1 plus b sub 1 and y sub 2 equals... Just bear with. We're not going to try to get too technical, okay? They're two different... Let's just pretend they're two different equations, okay? I know they look identical, but let's just pretend they're two different equations. What I would do is substitute into this equation, and what ends up happening is we do work, okay? Work occurs, and this is what I end up with. Let's say 2 equals 4. Like when I was done with everything, I ended up with a statement like that. 2 equals 4. Well, that's not true, right? That's false. So when you're doing substitution and you're doing your work, and at the very end, you get a false statement. Not x equals 5, not y equals 3, but you get 1 equals 7, 2 equals 4, negative 3 equals 8. And you're like, that's not true. If your statement is false, then you write no solution. Okay? So you're going to say, if it's false, write no solution. Okay, that's how you know your answer is no solution. The statement at the end is false. Okay? Now, the third option is infinitely many solutions. Remember, we call this IMS, right? Infinitely many solutions. Okay? So, infinitely many solutions starts the way no solution is. They say, okay, you get y equals mx plus b, and you're going to have another equation. By the way, they don't have to be in slope-intercept form. They could be in standard form, meaning like they may not be solved for y. They could be like 3x minus 2y equals 8. I mean, they're just two equations, okay? You're going to substitute in, and you're going to do some work. Okay, and then what you end up getting is like 4 equals 4. Or 8 equals 8. Or negative 3 equals negative 3. Or 0 equals 0. Okay? You end up with a true statement. If it's true, then your answer is infinitely many solutions. Okay, so let me write that down. If it's true, then write IMS. Infinitely many solutions. So as long as it's true, if it says 2 equals 3, what do I write? No solution. Good. If it's 7 equals 7, IMS, right? So the no solution and the IMS depends on, is it a true statement? Is it a false statement? The one for the answer being a point will not end up in like a number equal to a number. It's going to say like x equals 7, so we got to figure out what y is. So that's a little different, okay? But I just wanted to show you the 3 types of solutions that could occur, okay? So I'm kind of zooming out just so you can see the 3 types of solutions that could occur whenever you're doing a substitution problem. You're either going to get an actual answer, a point, or you're going to get no solution, which is a false statement, and infinitely many solutions, which is a true statement. Okay? So before I do question 2, because I don't want to start off with the no solution problem if that's what the answer is, let's take a look at number 3. Okay? Now I'm going to write these somewhere else. I'm not going to do my work in this area. I'm going to kind of write them on the side, okay? So let me see. Y equals negative 3x minus 12. So let me do that over here. So, number 3. Y equals negative 3x minus 12. Hold on. Right now I'll write them down and move out of the way here. 2x minus y equals negative 13. Now, one thing that I want you guys to know when I do my work here, whenever I do substitution, I always write my equations side to side. I never do one on top of the other. Okay? you need to be able to work vertically on each side. So I have to do them side by side. That makes the most sense for me, okay? Now, do you guys see how one equation, y equals to negative 3x minus 12, it's already solved for y, right? The other equation is not. Since the equation on the left side is solved for y, it's saying anywhere you see y, you can write negative 3x minus 12. Okay, right here. Anywhere you see the letter y, you can replace it with negative 3x minus 12. So what I'm going to do is I'm going to plug that in there. Okay, so check it out. 2x minus negative 3x minus 12 is equal to negative 13. So like I told you guys, I like to use colors just so you can see what changed. Right? Instead of that y being there, I put negative 3x minus 12. Now notice this is all algebraic work. This is that reasoning, like why do we want to use substitution? Because we don't want to graph and we feel okay with doing algebra. This is that part right there. We're going to do some algebra here. So let's go ahead and distribute in. So this is 2x plus 3x plus 12 equals negative 13. Okay, 2x plus 3x, what does that give me? 5x plus 12 equals negative 13. To solve for x, what do I move? Subtract 12, all right, good, both sides. What does that give me on the right side? All right, negative 25, thank you. So what's my last step here? Divide by 5, right? So divide by 5. And here is where most of my students mess up. And I want to make sure you guys understand. This is not my final answer. My answers are supposed to be what? A point. That's not a point. That's just an x value. I need an x and a y. But this is a good start. Okay, I'm going to put not really a box, but more of a dashed box, just so I know, like, hey, you're making progress. Don't stop. Okay? Where do you think I get to plug in that x value? Into the first equation now. Okay? You guys remember that song from Lion King, Circle of Life, right? This is what you do. We're going to go around the circle. Notice I went from left to right. Look at that arrow. Okay, from left to right. And what I'm going to do now is I'm going to go right to left. Okay? I'm going to go back to it. All right? Let me make this thing a little wider here because I don't want to jump into it. But we're basically going around in a circle. We start from one, we push information into the other, work our way down, and then go back. Okay? So that x equal to negative 5, I'm going to plug it in. Y equals negative 3 times negative 5 minus 12. Well, negative 3 times a negative 5, that's a positive 15. And 15 minus 12, that's 3. Again, this is not my answer, but I'm almost there. I got an x value, I got a y value, so all I got to do is put them in the form of a point. So here's my solution. Negative 5, comma, 3. That's my x, y. Now if you were to go on Desmos and graph these two equations, you would see that it's going to give you your answer at negative 5, 3. It's going to put it there for you. So you might say, oh, well, why do I want to do it this way when on Desmos I can find my answer in like 3 seconds, right? The reason why we learn to do it this way is because you're not always given the opportunity to use a graphing calculator, to use a graphing app. So either you have to graph it by yourself on a piece of paper, and I can almost guarantee you that if you do it on a piece of paper that does not, where you have to draw your own graph, the chances of you getting that point are really tough because our lines are not always perfectly straight. We don't always put perfect spacing between our tick marks, right? Now, if they gave you a nice piece of graph paper, maybe you can actually get the right answer perfectly. But if you draw it yourself, the chances that you get negative 5.3 are pretty small. You're going to be a little off, just a little bit, right? But even that can cause an error. So if you don't want to draw it, then this is what you do. You're going to put your two equations side by side, okay? Substitute into one of them. Do the work to find an x or a y value, whatever it happens to give you. And then substitute it back to where you started from. Okay, you're going in a big circle, okay? Start at one point, go to the other, do work, and then go back to the beginning where you started, okay? And that's how you find your answers. Now, if we go over to number 3, just so we can see our answer here, negative 5.3, it's right there. Negative 5.3. That's my answer. Now, this one's considered a medium difficulty problem. The reason is one of the equations was already solved for us. That one was already solved for us. Look, there's the y value. Y equals, right? The ones that are considered easy are these. Look at how for number 1 it says y equals that and y equals that. They're both solved for y. Same for question number 2. Y equals half x plus 1 and y equals 3x minus 4. They already solved them both for y for me. So those are considered the easy ones. The hard ones are like numbers 5 and 6 and 7 and 8. Notice none of them are solved for y. So I get to do it. So that's why they're harder. Some already solved both of them for you. Some solved one of the two. And the other ones, none of them are solved. So that's easy, medium, and hard, right? The difficulty level. So let's go to the easy ones, like I said. Let me do question number 2, half x plus 1. So I'm going to write it over here. I just don't have a lot of room in that space, and I don't like to try to cram everything. So here's the first equation, half x plus 1, and the other equation was 3x minus 4. Notice again that I am writing them side by side, okay? Because I wanted to give myself room to work. Now, I usually go left to right, but it doesn't matter. You can go right to left, whatever you feel comfortable doing, okay? Whatever you feel comfortable doing. So, I'm just going to go left to right so I can draw this way. I'm going to plug into here. Now you see that right there where it says y is equal to half x plus 1? Y is that thing in yellow. So on the other equation, wherever I see a y value, I'm going to replace it with the thing in yellow. So half x plus 1 equals 3x minus 4. Okay, so I'm going to combine my like terms, half x and 3x. Since half x is smaller than 3x, I'm going to move the half x over to the right side. So this might be good for you if you have a calculator, you can use that. Or if you just want to use your head and do it in your head. Or, think of it in terms of a decimal, right? Half is 0.5. 3 minus 0.5, that's 2.5, right? So I get 1 equals 2.5x minus 4. Now I'll add 4 on both sides. So I get 5 equals 2.5x. And my last step is to divide. So divide by 2.5. Notice, even though this is considered an easy problem, I still am doing the same steps I did in the previous example, right? I'm still solving. So you don't get away from the solving part. It doesn't matter whether it's an easy, medium, or hard problem. You're always solving, okay? What's 5 divided by 2.5? Oh, that's going to be 2. Okay? There's my x value. It's 2. So where do I put that answer? Where do I throw that x equal to 2? Yeah, put it back in where the yellow stuff is, right? The stuff that I used to plug in, you're going to put it back over there. So here we go. Y equals 1/2 times 2. That's my x value. Plus 1. What's half of 2? What's half of 2? 1, right? So this is 1 plus 1, which is 2. There's my y value. So here's my answer. X is 2, y is 2. And there's my solution. So I was a little worried that this was going to be a no solution. That's why I didn't do it first, because you don't really want to start with a special case when you're trying to teach people something, right? But it turned out it actually does have an answer. The answer is 2, 2. So I would just go back to my question number 2. Let me do that really quick and highlight that for you guys. So it's right there. Like I said, I was worried that it was going to be a no solution, and usually you don't want to start with special cases when you show your first example. So I went away from it. But I could have started with this one. It would have been fine. But let me go back to the works in case you're still writing it. I'll give you a little bit of time to just finish that off. And we're going to do one more. We'll do a hard one. Okay? We'll do a hard problem. So we've done easy. That was question number 2. That's an easy one because they're both solved for y. We did a medium one. That was question number 3 because one of them was solved for y, but the other one was not. And right now we're going to do one that's considered difficult, okay, in which none of them are solved for y. So we get to do it, okay? We get to do it. The nice thing is you get to pick which one you want to solve. So that's kind of nice that you get to choose. All right, so let me look at, maybe we'll do number 7, but we'll see. I think doing number 7 would be a good call. Let's try number 7. Okay? So if you want to write them down left to right, go ahead and do that right now. I'm actually going to do number 7 on this screen right here because notice there's a bunch of white space, so I can write them out and do it. So I'm going to do it right here. So number 7, I get 3x plus y equals -5. And I also have 6x plus 2y equals -15. None of these are solved for y or even x. By the way, you could solve for x as well. It's up to you. Solve for a letter, any letter you want. Okay? Which equation looks like it might be easier to solve for either x or y? The one on the left or the one on the right? The one on the left. Which letter would you solve for on the left? Yeah, I would solve for y because it's pretty much just there by itself. I just got to move stuff over. What should I move to on the left side? What should I move to get y by itself? The 3x. All right, thank you. So here we go. Let's subtract 3x, okay? So minus 3x on both sides. So I get y equal to -3x minus 5. Now you notice how we just solved for y, so I'm going to kind of highlight that for us because that's a good thing that we have that right there. Now that I know what y is, I get to plug it in to there. Notice how we didn't start by going left to right like we did in the other ones, right? We just kind of said, okay, get this, plug it in, right? We couldn't because we didn't know what to plug in yet. We figured out what to plug in. And now we're moving it over to the right side. So let's plug it in. That's 6x plus 2 times -3x minus 5. Notice the y disappeared and I plugged in that thing in red. Okay, equals to -10. Remember, these are called the hard problems. Why are they called the hard problems? Because of this right here. Just that step right there. That's why they're like, oh, it's so much harder, right? Why? Oh, because I had to solve for something first, right? You might say, well, that's not that hard. Well, good. Then that means there are no hard problems for you, right? But that is the part that people sometimes mess up on. So they're like, okay, this is the difficult part where they have to solve for a letter. That may confuse some kids. So these are obviously a little bit tougher to do. But anyway, let's go ahead and distribute. We got 6x. Remember, we're distributing here. So it's going to be a negative 6x minus a 10 equal to a negative 10. What happens if I try to simplify here? Anybody see anything weird that's going to happen? What's going to be 0? The x is 6x minus 6x. What happens to them? I mean, you said zeros, right? They cancel out. Right? They disappear. What am I left with? Let's see. Negative 10 equals negative 10. Do I have a letter to solve for anymore? No. Is that a true statement, though? Yeah, and what am I supposed to write if it's a true statement? IMS, right? Infinitely many solutions. So there it is. B. If that would have said 10 equals negative 10, what would I write? If it's 10 equals negative 10. No solution, okay? That's what a no solution problem would look like if it was like that. 10 equals negative 10, that's no solution. We got negative 10 equals negative 10. That's a true statement, so we write infinitely many solutions. Okay? So there you go. That's what that would look like in that case. So I'm gonna give you guys. I'm gonna stop now because that's gonna give you 20 minutes to kind of work on stuff. Let me post your assignment and work on it.